All right, our identity and equality properties. Let's go. Okay, so we're going to start out with some key concepts here and, just fill in the things that are open here. So the additive identity for any number a, and the sum of a and 0 is a. So basically anything plus 0 is the same number. So 5 plus 0 is 5, 0 plus 5 is 5. Sounds silly, but we got to say it so we make sure everybody's on the same page. All right, so these three are more properties, but these are multiplication. So multiplication identity, any number, product, and 1 is the original number. So a number times 1 is this original number. So 12 times 1 is 1. Okay, so multiplicative property of 0, any number times 0 is 0. A number times 0 is 0, so 8 times 0 is 0. I know these are hopefully these are just review, but we got to say them anyways. Multiplicative inverse. This one is going to be a key when you have fractions and algebraic expressions. So for any number a over b, where b can't be 0, there's exactly one number, b over a, that's the switch, a over b, b over a, such that the product of a over b and b over a is 1. So basically what that's saying is if you have the multiplicative inverse, a over b times b over a, it should equal 1. Will equal 1. So 2/3 times 3 over 2 equals 6 over 6 equals 1. Same thing, 3 over 2, 2 over 3, 6 over 6 equals 1. So when we have fractions is where this multiplicative inverse comes in really handy. All right, so let's do some identifying of properties first. Name the property used in n times 0 equals 0. Then find the value of n. So what number times 12 equals 0? Well, it would be the multiplicative property of 0, because any number times 0 is 0. So n would equal 0. Name the property used in n times 1 over 5 equals 1. Then find the value of n. Well, the multiplicative inverse would be 5 over 1. So as a multiplicative inverse property and 5 over 1, which would also equal 5. Since 5 over 1, and now that we're back after this brief message from a package got delivered to my house, yay! Okay, so 5 over 1 times 1 over 5 equals 1, so n equals 5. This is a multiplicative inverse property. All right, pause this one and let's give it a shot. All right, so name the property used in n times 1 over 3 equals 1. Well, to get something to equal 1, it's got to be the multiplicative inverse property. And n has to be 3 over 1, which is equal to 3. So n equals 3. So a. Name the property used in n plus 0 equals 11. Well, that would be n has to equal 11, so it's one of these two. It's not multiplicative, so additive inverse property. All right, a few more things here for properties of equalities. So a reflexive property of equality is any quantity is equal to itself. So a equals a, 7 equals 7. Or you might end up with, this one's a little hard to see, so 2 plus 3 equals 2 plus 3. Those are equal to each other. That's going to come in handy later because we can do unto one side of the equal sign as we do to the other. Symmetric. For one quantity equals a second quantity, then the second quantity equals the first quantity. A and B. If B equals A, then A equals B, then B equals A. 9 equals 6 plus 3. Then 6 plus 3 equals 9. So I can switch them around and they end up being the same. That's symmetric, symmetrical. Both sides are the same. Transitive. This is the one we use more often. If one equality equals a second equality, or second quantity, and then the second quantity equals a third quantity, then the first quantity equals the third. So for A equals B, B equals C, then A equals C. So this is, I call it the cut out the middleman property. So we could say A equals B, B equals C. I can cut out the middleman, and therefore A equals C. So what that looks like in numbers is 5 plus 7 equals 8 plus 4. 8 plus 4 equals 12. Therefore, I can cut out the middleman of 8 plus 4 and say 5 plus 7 equals 12. Substitution, we'll do this a lot. A quantity may be substituted for its equal in any expression. So if A equals B, then A may be replaced by B in any expression. So if n equals 15, then 3n equals 3, and then we substituted 15 in for n. All right, so let's see what these look like in some examples. So name the property used in each step. So we're going to, PEMDAS this out. So first thing we're going to do is we're going to do the parentheses. So we're going to subtract these out. And in order to do that, we're substituting 4 for 12 minus 8. Then we're going to do the multiplication inside of here. So we're substituting 3 for 15, or 5, or 15 divided by 5. All right, next one we're going to do is inside of here. We're going to do this substitution. So 3 minus 2 equals 1. So we're substituting 1 for 3 minus 2. Keep on going here. So to get 3, let's back it up so we can see what here. 3 times 1, well, that's a identity solution, or multiplicative identity, because 3 times 1 equals 3. So we're using a multiplication identity to get that one. 4 over 1 times 4 is also going to be a new one. So multiplicative inverse, because they are inverses of each other, therefore they equal 1. So we took 4 over 1 times 4 equals 1. And now we're going to substitute 4 for 3 plus 1. And then we would check that off. Answer equals 4. All right, try this one on your own and go. All right, let's break it down. So I'm just going to work straight down. It'll be easier that way. So we're going to substitute 3 for 10 minus 7. 10 minus 7 equals 3 plus 4, and then 18 divided by 9 minus 1. Okay, so multiply, divide, then add, subtract. So 18 minus 9, we're going to substitute that together. Sorry, my terrible plus sign. 4, and then that's going to be 2 minus 1. And then we'll just keep that there. Do this one into here, plus 4, and then that turns into 1. 1/3 times 3. That's going to be a identity. Equals 4. This is going to be a multiplicative inverse. 1. 5 plus 1, substitute 5. And that's it. Come to class ready.